You ever try and put a puzzle together? You've got pieces, you got to move them around. You may not have it right, so you got to rotate them, select them, kind of push them around at different places on the table to see if they fit. So when you're creating a puzzle, you've got to move and flip pieces around to see if they actually fit into what you're trying to do. And if they don't, you have to manipulate them a certain way, move them around, and then things start to kind of take shape of what you're given in this part of a puzzle. So it's always easier if you start with putting the edges together to see what will fit, what won't, but you're always moving pieces around. You're trying to figure out the best way to put them together, and that takes time with what you're looking at. So when you're done, your puzzle looks like this. This is a part of what you're going to do in this section for the geometry of moving things around in different ways and different orientations. So let's define some of those terms as we go. Two terms to start out with are translation, which is moving an object at a certain distance, and isometry, which is the shape stays the same size. So it doesn't change anything. So when we start with an image and we have this rectangle here, this is what we call the pre-image. What we do is when we slide it, and they'll give you kind of the translation or transformation arrow that they give you, which shows you we're going to move it from here over to here. We're going to put that into the image, which is the final object that you have, and it's the same size, same shape as you look at it from what you were given to what did the movement for that. So our first definition is translation. Translation is just simply moving an object a certain distance. So one of the terms that will come up in this section with translation is, because we're not going to get into it too much, is what's called isometry. And that means that the shape of this object is not going to change. It's going to stay the same. So the prefix iso means same. So when you look at what we have down here for the pre-image is what you start with. And that is, could be anything that they use for a shape or design or picture or whatever. Once they translate it, and they show the translation using an arrow for this, and as you look, you see that it's going to get translated along this line in this direction, and the shape of this stays the same, and that's what we call the image. So the image is the end result of the translation. So another term that we're going to talk about is what's called a flip or reflection. So if you think of a mirror, when you have, you look into something, your right is now your left is now your right. So a reflection is simply you're flipping the object. Now one of the things that we have with this is what we call the line of reflection. And the line of reflection is a line that always goes in the middle of that. So when we do look at some of these, this point is exactly the same distance away from the line of reflection, and you could draw a point here and this point. These are the same distance away from each other as these points here. So this point at the end of the arrow is exactly the same distance away from there. So reflection is just simply you're flipping the object over an axis, and we'll talk more about that as we go into this. For the second part, rotation Rotation is you're turning a certain degree or direction. So that might be, you might move it clockwise or counterclockwise. You may move it 90 degrees, which is a right angle. You may move it 180 degrees, which is basically a straight line. So you're taking an image from here and you're moving it across. You may go a little, you may go more, because you can go in a 360 degree, which is a circle orientation. Now the best way to do this part of it, and I'm dead serious when I say this, is take this and put it on a piece of paper, and when you take the paper, you just simply rotate where you're going to go, and that is now the new orientation of this. So if I get rid of some of this stuff over here that we've already talked about, which you can't, what you're going to see is now this is your x-axis here, this is your y-axis here. Once you've done your rotation of, depending on if it's 90, if it's 180, now what you're going to do is you're going to relabel your axes, and this one is now going to be your x and this is going to be your y, and then you figure out what your points are. So that's the easiest way to do this, is just basically take your pencil, put it in the middle of your object, and rotate the paper, or just simply rotate the paper either clockwise or counterclockwise as you do this. So a translation itself is simply just a slide. So all we're going to do is we're going to just slide the object in some direction. Now what they'll do is they will tell you by using an arrow which way, and also the size of the arrow is going to tell you how far you go with what you're doing. So if we're moving this from this point here, we're going to translate it in this orientation. Now be careful on this one that you do not rotate. We do not want to do that because that changes the orientation of the object. It changes the look of it. We don't want to in a sense make it smaller or bigger. We don't want to do that either. We want to stay in the same shape, and that's where the term isometry comes from, that iso part of that word, keeping the same thing. So translation, we're just sliding this thing like we're sliding the words around on the paper. We're just sliding it here and there. That's all translation is. So when you put it on this, some of the times it's easier to cut things out, get some what's called dot paper, and that's what you see on the screen here. And we're just going to slide this triangle the length of the arrow, and we're going to stop it here. Now what happens with most people is when they move it, they will take it and they will turn it, and that's not what you want to do. You want to keep it in the same orientation that we started with, and we just want to slide it along the length of that arrow until it gets to the end. And then that way you can see, okay, where did this thing go? So it's basically, if you think about moving furniture in a room, this is what you're doing. Go back to the puzzle part that we started with. Also with translation, you can put this on a grid system, and if you have questions on this, this is something that should have come from 7th grade math in regards to the coordinate system that we're using. So what we're going to use is we're going to use points on the corners of this rectangle. It's being told that we're going to translate it in this orientation, meaning we're going to, this is your x value, this is your y value. If it's a negative, we're going to take it and go to the left 3 places, and then we're going to go with the y, we're going to go up 4. Now, in regards to graph paper, this may not work in regards to what we have here. So if you look at what I have, we're not going to be able to move it 3 places to the left because we're going to run out of room over on the right hand or left hand side of the screen. So let me change this part of this, and we're going to take this and put a different number in. Let's say we're going to move it 4. So that means now instead of moving it left, we are going to move it right, and we are going to move it up 4. So we're going to take each of these points of the rectangle that we have, and we're going to move it 4 places to the right. We're going to move it 4 places up. So if we count, we're going to go 1, 2, if I get my pointer out here, we're going to go 1, 2, 3, 4, and then we're going to go up 4, 1, 2, 3, 4. So really what we're doing is we're translating this object in this direction. So what we're going to do is we're going to simply move the object that we have here for this, and we're going to reorganize it into a different spot. So we're going to take, and I'll do this in different colors, we're going to move this one 1, 2, 3, 4, 1, 2, 3, 4, and that's our point for this corner. So we're going to do the same thing for this one, 1, 2, 3, and then, or 4, and then 1, 2, 3, 4. And generally, once you get 2 spots in there, you kind of get an idea of where the next 2 points are going to be at. Because if you count how high this thing is, it's 1, 2, 3, 4. So we just go 1, 2, 3, 4. So that puts our top 2 corners up here. And now we have a new translation of where we move the object by an ordered pair for this. So not as tricky, but it's just getting in, remembering how to do the order of or ordered pairs for that. So we get a little bit more specific in this with what we're dealing with. The mathematical notation of this is going to be your point location of the black dot here is the original -6, -4. What they're doing is they're telling you in the problem, we're going to translate the ordered pair, we're going to translate it 5 and 2. So the x is going to go 5, the y is going to go 2. Now there's 2 ways that you can do this part. You can do this on the graph itself, which is what I showed you over here. So that's the translation of this moving in that order. And then you could also do it the mathematical way, which is shown here, and that is you simply take your x value and your y value and you take it by what the translation actually is of that point. And that gives you the new order pair of where that point would be, and that shows you the translation of the motion. So thinking of this as a house, I hope my black boxes move here. We can take and move something over to this side of the room. That's a translation. I can take this black box and I can turn it, so I can rotate it, and I'm rotating in a certain degree and direction. The other one is I can reflect it, which is hard to show you on this part, but we can move it if we had this black box here and we reflected it over the other side of the room, we would put it here, so that would mean that the line of reflection is going to be in the middle of the room. Bad choice of color there. Middle of the room, and we would just simply be the same distance from that line of reflection. So as you go through that, that's kind of how it works in regards to putting the terms to work with some of the real stuff as you do this. So really in this section, use the examples that we went through, a lot of visuals, draw it out, put it on a different piece of paper, manipulate the paper, manipulate the drawing that you put on your paper. If you need to, cut it out, move it around, ask me for some dot paper so we can get that taken care of. Anything that will help you see it, you want to actually do it. So good luck with this section. Use your notes and ask questions.